Okay, we're going to talk about the meeting point project, and quick thing, in the criteria for the rubric, it says that you need a clear statement of time when the cars meet. That should say position. Okay, so keep that in mind. Now, clear statement of position. Now let's talk about what is happening with your scenario. What is happening here is that you have fixing something here, guys. You've got a distance. This distance is 1.5 meters, and we're going to follow our problem-solving steps. So we're going to determine our origin. We're going to say our origin's right here on the left, which means positive direction is that way. So it's 0 meters, and the slow car is going to start over here at 0 seconds. And now third period, I think you guys we talked about it in your class the other way around. It's perfectly fine. The idea is still the same. So we have 0 meters and slow car at 0 seconds. And on the other side, we have at 1.5 meters, the fast car is going to take off at 3 seconds. It's going to go this way, and the other one's going this way. Fixing some signs. So here we go. Now you can pretty much read those just like coordinates. So that if we were to draw a graph of this scenario, which I'm doing right now, if this is our position, this is our time, this is a sketch, it's not a full-on graph, guys. We could say that at 0 position and 0 seconds, our slow car takes off. And we could say that at 3 seconds, wherever that 3 seconds is, there goes my fast car. Okay? So this right here, this part, so from here we can go ahead and start thinking about what's happening. So we already have our positive direction. And now we're doing part 2 of problem solving, which is going to be to break our motion up into pieces and focus on which piece of motion we're looking for. Well, right here, whoops, not there. Okay, what I'm doing here is just moving some stuff around. Give me 1 second. Okay. This part right here, this is where it meets. I'm going to move this entire thing up a bit so we get some room right underneath. Okay, so this is where it meets. That means it is also essentially what we're looking for, because right here is the final position, the meeting position, X, we'll say, I think I've been using D in class, the meeting position. Okay, so we have those 2 places. Our job is we need to figure out ultimately what is that. Okay, so let's see what we do know. So we've just broken part of it up, but there's more than just that one piece. If I look at the beginning of this graph, I see that there's another piece in here. And that's right here. At this point, this is 3 seconds. Okay, so if that's 3 seconds, that means that this entire piece right here, the entire first leg that I just highlighted, that right there is when the slow car is moving by itself. And if we know the time, then we know how far that car goes in that small period of time. Let me go ahead and put a different color in here. Okay. Then we can figure out right here, this is how far the car goes in the very beginning. So we'll say this is the displacement, the first slow displacement. That is something that you can figure out. Okay. Now, so we've kind of broken it up. We have 2 big pieces of motion. And So we got our first part, that's the first 3 seconds. The next part is, well, it's this part right here, from here to here. Okay, so we have to figure out what's going to be the same and what's going to be different. Well, we already know that the velocity of each one, this one and this one, they are different velocities. One's slower, one's faster, one's going positive, one's going negative. All right, and we know that they're going to cover different distances. We can kind of tell that just by looking at our graph. We don't know what they are. We know they're going to be different. The one thing that is the same between these is the amount of time travel, the amount of time that it goes through together. I call this whatever you want. I'm just going to call it T for right now. So the fast car and the slow car are going to go the same distance, the same period of time after they're both started. Okay, so there's a time in there. What else can we figure out from here? We're just kind of labeling things. All right, so let's go over on the y-axis. So if we're going on the y-axis, I'm looking right here. So if that's the slow part 1, that makes this part, we'll call that DS2 for slow 2, not for Nintendo. Okay, this part we don't know. This part we do. Okay, all right, so there's the D slow 2. Then what else we have? Okay, so we can see now that if you're looking at the full thing, that DS1 plus DS2 is the entire distance that the slow car has moved before the intersection. And that makes this part right there as far as the fast car is gone. Oh, if we're to label this right here, where this started, this would be your 1.5 meters. So that makes this, whoops, that makes this part how far the fast car went. And again, we don't know that. So we know on the y-axis, we know 4 things. Rather, there's 4 things to consider. We know the slow one. All right, we have to calculate it, but we know it. It's our velocity, and the time of the slow car will give us the distance it goes in 3 seconds. We know we need to find out the slow car, part 2, and we need to find out the fast car, but we know the total distance we're covering. Okay, so that gives us some information. We do not know the time of the meet, and we do not know time t. Okay, but what we do know about that time is that it has to be the same amount of time that the fast car is going, and it has to be equal to the amount of time that the slow car is traveling in its second portion of motion. Okay, so we can go ahead and we can use that. Whoops. Okay, so there are some unknowns. Okay, so we've got a final we don't know, we got a slow we don't know, we got a time we don't know. Let's figure out how we can use this. So we already know that we've got velocity equations. We're going to have one for each car. Okay, so if you think about what's going to happen, you're going to have a velocity for one car, equation for one car, and a velocity for another. And the thing that links them is that time. Okay, so keep that in mind. You're going to be able to use that. The fact that they have the same time will let you start creating your system of equations. So you'll have one velocity equation for your slow car and another velocity equation for your fast car. So that gives us a couple of things. And let's see here. So let's come in here. I think we're still going to be short an equation because we're going to have a velocity 1, and we're going to have a distance here that we don't know. All right. So this is our, whoops. If this is our fast car, that means that this is the fast car's distance. Okay. If we have a slow car, that's going to be the slow car's distance. Okay. All right, specifically the second one, and there's our time. Again, that's what we don't know. So for what I've just written, we have three things we don't know. We don't know the time, we don't know slow to, and we don't know fast. So there's two equations, but so far we have three unknowns. 1, 2, 3. So I think we need one more equation and one more equation to make this work. Let's take a look. So we already know this right here. If that is if this is the displacement, the slow goes in 1, we know that. Okay, that's the amount that goes in the first 3 seconds. Here's the displacement that goes in the second period of time. We don't know that. And I can give myself some more room for there. Okay, it's just taking a second here. So I had a bit of a pause there. So right here, that's where that we know that is the distance that the slow car covers in 3 seconds. Here's something that we don't know. We do not know how far the car covers in the second time. And we also do not know how far the fast car covers in the second time. Okay? So if we look at that, it's not a standard equation, but it is an equation. Because we know that 1.5 meters is equal to how far the slow car went in the first 3 seconds, plus how far the slow car goes in the second bit of time, and how far the fast car goes in the second bit of time. So we have this, and we're looking for these two. Okay, so now I can use this to solve for slow car 2 or the fast car, and then come over and use it again in whatever my variation of my displacement equation was. Okay, so you have all the pieces. This is a system of equations. Start by listing your variables. Okay, it's not going to be this one, because this is what you use when you're dealing with kinematics with acceleration. It's just that's a tool specifically for that type of scenario. But you can still list your variables. Think of everything that we've got written on this page. What do I know? Do I know a velocity of the slow car? Do I know the velocity of the fast car? Do I know how the distance that the fast car will travel? All right, just start writing down everything you know and say, I know this. All right, whatever your velocity was, I know this. This is a number I have. Or this right here is a number I don't have. Just list everything that you've got. Write down all the equations that you can come up with and start rearranging them. It's a system of equations. You're going to end up with 3 unknowns, so you need to have 3 equations, and you can go ahead and solve from there. We're going to test this on Friday. There will be up to 10 insurance points on this project. Up to 10 insurance points for being within plus or minus 3 centimeters of your prediction. Good luck.